Good day, sirs and madams. We are very glad that you could join us for our tour here at Frosty Institute. It is our most sincere hope that by the end of the tour, some of you will be interested in joining us in our studies of cryogenics. Firstly, you may ask, what is this cryogenics of which we speak? Cryogenics, in short, is the study of cold temperatures and how materials react to these cold temperatures. Of course, cold can encompass negative 20 degrees Celsius when we all bundle up to go pick up the newspaper from the curb. It could mean 12 degrees Celsius near Ecuador. Here at Frosty Institute, cold means close to absolute zero temperatures, which is 0 Kelvin or negative 273.15 degrees Celsius. Why bother to make such cold temperatures when they are inhabitable by humans? Well, cold temperatures serve many purposes. For example, at near absolute zero temperatures, nitrogen gas is turned to liquid. In addition to nitrogen, argon, helium, hydrogen, and oxygen can also be liquefied for many other uses. These are used in refrigerants, oxidizers, and fuels. Liquid nitrogen can be used for various things, such as protection of flammable or explosive materials when exposed to air. It can also be used as a shield gas for other materials. Cryogenics has many other broader uses. Creating extremely cold temperatures can make certain materials superconductive due to the lack of electrical resistance. Also, when dealing with auto parts or surgical tools, cooling them causes for less wear and tear, so that constant replacement is not necessary. Some other, more common uses of cryogenics is the cooling of instruments to improve its tone. I'm sure you've wondered why your guitar isn't sounding its best. We can help you fix that here at Frosty Institute. Now to inform you about the finer aspects of cryogenics. Steve?
Thanks, Anne. To start off, cryogenics is all about the gas laws. All cryogenic liquids are gases at one point. If you don't remember anything about gases, think about it this way. They're empty space. Gas particles take up no volume whatsoever. They can be compressed and they have loads of energy. For all you high school dropouts, they move around rapidly within their container, and if allowed freedom, they expand until they reach their limits. Just like diseases. That just gives you the best opinion about gases, doesn't it? Well then, here's what you need to know for the cryogenics aspect of gases. There exists a temperature, a critical temperature, at or above which no amount of pressure will be able to liquidate the gas.
Don't you mean liquefy?
Liquidate, liquefy, same thing. But if it helps you keep your cool, then sure, we'll go with liquefy. Anyways, as I was saying before being so rudely interrupted, was that if a gas is at a temperature below the critical temperature, if enough pressure is applied, the gas will liquefy. The minimum pressure required to liquefy a gas at or below critical temperature is known as the critical pressure. That's the main aspect of cryogenics that requires knowledge about gas laws. So, if any of you guys haven't studied high school chemistry, either you believe all us employers to be at a state of constant brain freeze in the whole deep freezing world of cryogenics, or you're just stupid. You can't do this job without the gas laws. You need to calculate exactly how much pressure would be required to liquefy a gas, or how much gas a cryogenic liquid would produce, or at what temperature would a certain gas need to be at for its liquefaction. The gases stay at a liquid state because as temperature decreases, the gas starts to behave lesser like an ideal gas, a gas that respects all the gas laws, just like people. At low temperatures, the gas particles don't have a lot of energy between them and stick closer to each other. When the pressure is added, the gas particles start to attract each other, which is a liquid property. Now that we've completed all the science stuff, let's get to the science fiction. Here's Bob to inform you about the best part of our business.
Now I bet you've heard of those seedy organizations who sell immortality to unsuspecting victims. And I'm here to tell you, those rumors are true. And for the low, low price of $400 a year, we can freeze your body or corpse and wake you up when the ability to resurrect the dead is available to us. It all starts when you are pronounced legally dead. A crack squad of highly trained commandos is dispatched to collect your body. They supply your brain and blood with enough oxygen for minimum function. You are then transported to the nearest Frosty Institute facility, where you are packed in ice and then given to the medical team. Your body is then vitrificated by removing the water from your body so it does not freeze. The water is replaced with a chemical known as cryoprotectant. You are then cooled by being placed on a bed of dry ice. Once this process is finished, you are placed upside down in a pod which contains liquid nitrogen at a temperature of 196 degrees Celsius. The vitrification process is not cheap, you know. It costs $150,000. But for those budget spenders, we offer a cheaper process known as neurosuspension, where we freeze your brain. This process only costs $50,000. You'll be placed in a bath of nitrogen known as a neuropod with a couple other of your cryogenically frozen buddies. Ain't that quaint? So remember, cremation is not cool, but cryosuspension is.